I forget, did I start any of these? Yes or no? Do you remember? No? Yes? Maybe? Alright, so let's take a look at a couple of these. Let's take a look at number 1. Okay, so we are boycotting the quadratic formula. Yes? You feel good about this? We're boycotting it? Alright, so if we want to go and solve the equation by completing the square, let's see who remembers from 2 days ago. What was the first thing I should do on number 1 to start completing my square? Yeah.
So you want to do an x to a second minus x down.
Okay.
And equals -2.
Yeah, I'm going to move this over by subtracting it, but I'm going to leave the space still there, right? All right. That's exactly right. So move the constant, move the value that doesn't have the x, move it to the other side. If it's already over there, then it's one step ahead. Then we're going to say, okay, x, and it's going to be quantity squared. What is the sign going to be? Positive or negative? Negative. It's negative in front of the x term, negative here. Take half of 4. Half of 4 is 2. 2 squared is positive 4. So we get to this. Root. Don't forget the plus minus. I'm going to get x minus 2 is equal to plus or minus root 2. Add 2 to both sides, and you just wind up with the answer like that. And that is so much faster and so much nicer than the quadratic formula. It would have been the same answer, but you still would have been working it. Right? So number 2, same idea. We want to move the 5 over by subtracting it. So I'm going to get x squared plus 2x equals -5. Okay? So come down here. X, is it positive or negative next? Positive. In front of this term is positive, so it's positive here. So half of 2 is 1. 1 squared, or 1 times 1 is? So I get to there. Agree? Root, don't forget that. Plus minus. It's going to have an I for the answer, so the square root of 4 is 2. So I get plus or minus 2i. Agree? Then subtract 1. And it's done. Again, quadratic formula would have done it as well. It would have taken a lot longer, which is not as nice. Because we got to save time so we can doom scroll, right? When you bust out the phones, you got to see what's going on with the world. And give up months of your life. All right, friends, can I get rid of this? Anyone still writing? Going once? Twice? Sold? All right, let's move down to problems 3 and 4. Okay, done the same way. Okay, move the -5 over by adding it. So I'm going to get x squared plus 2x is equal to 5. Make sure you leave that space. Down here is going to be the same. X, it's going to be positive because there's a plus there. Half of 2 is 1. 1 squared is 1. Root. Don't forget the plus minus. Root 6 won't break down any further. It's not the negative, so we don't have to worry about that. Subtract 1. Done. Friends, does this seem easy? Have I changed the rules at all on any of these problems? That's the big problem with a formula, because sometimes with a formula it's like, oh, but this had that 3 in that weird spot, therefore you have to do this. I'm like, how am I going to remember that? All right. Number 4, it's already set up for us to do. We just have to make space. Agree? All right, as we go through it, x plus. Don't be afraid of fractions, okay? Half of 5 as a fraction is what? 5 over 2. 5 over 2 squared. 5 times 5 is 25. 2 times 2 is 4. Bless you. I'm going to change this. I'm going to make that. I'm going to multiply both sides by 4 and 4. So that's negative 32 over 4 plus 25 over 4. And negative 32 plus 25, that's going to give me negative 7 over 4. Root, don't forget the plus minus. X plus 5 halves equals, it's going to be I root 7 over 2. Wait a minute, why did the denominator become a 2? I took the square root of it. Bottom had a perfect square. I forgot the plus minus. Sorry about that. Bring the plus minus. Subtract the 5 halves from both sides. If you wanted to clean it up, you could clean it up to be this. Honestly, I'm good with either answer. You don't have to go and list both. Cool. So the big thing, the big devastating part of doing this is if you get hung up on a fraction, but I will tell you the graphing calculator will do fractions very well. If you ever want me to show you, let me show you. It works very well, and it will give you the answer as a fraction too, which is great. All right. Can I clear this? We're good? Okay, delete. Boom. All right, let's see what else we got here. That looks like that was the whole first page done. All right, so number 5 is already set up for us. We just have to make the space. All right, so x squared minus 4x, make the space. The 2's already over there. What's my sign going to be next to the x? A negative, because there was a negative in front of the 4. Half of 4. 2. 2 squared. Add 4 to both sides. Root. Don't forget the plus minus. Cool. Last step is add 2. Done. Okay. Number 6 changes gears a little bit. Agree? So let's move the constant over first. You agree with that so far? Because I have a number that is not 1 in front of x squared, what should I do to get it to be just x squared, not 4x squared? Yeah, divide everything by 4. Do not fear fractions, friends. Okay. Set up our parentheses. What did I say? How do you take half of a fraction? What do you double? The top or the bottom? If I take half a fraction, do I double the top or do I double the bottom? Bottom? So half of 1/4 is 1/8. Agree? Okay? 1/8 squared, 1 times 1, 8 times 8. Okay, so that one's a little nastier, right? So I'm going to squeeze it here. Negative 1/4 plus 1 over 64. I need to get a common denominator. Common denominator is going to be 64, so I'm going to multiply the top and bottom of this fraction by, let's see, 1, 16 and 16. That's negative 16 plus 1 over 64, over 64.
Excuse me, sir.
Hey, she's here.
You here? Thank you.
You got it. All right. Oh. All right. Let's see. If I do this math, that's going to give me negative 15 over 64. The nice thing is, what do you notice about the denominator on the right side right now? It's a what kind of square? What kind of square is the denominator? It's a perfect square. And that always happens with when you complete the square with this stuff. Root, don't forget the plus minus. X plus 1/8 equals plus or minus I root 15 all over 8. Subtract 1/8 from both sides. So if I subtract 1/8, I'm going to get this. I'm just going to combine it as one fraction right away. But that's my answer. You could have left it as negative 1 over 8 plus or minus root or I root 15 over 8 as well. But that's the answer. That's all you have to do. Oh, complete the square is such a good friend. I'm telling you. Those darn Algebra 1 teachers teaching you the quadratic formula. But we got a cute song. Yes, you did. You know what happened when Brown was in my Algebra 1 class? I taught the song. His mom emailed and said, he keeps singing this song. I was so proud of you. But your mom was all upset because I'm just kidding. She didn't email. I'm giving you grief, pal. All right, clear. Get rid of that. All right, those are, okay, cool. All right, ready? All right, let's make our space first. So 4x squared minus 2x, subtract 3. Agree with that so far? My x squared has a 4 in front of it, so I'm going to divide everything by 4. Don't fear the fractions, please. Those cancel, so I get x squared minus 1 over 2x equals negative 3 over 4. Do you agree with that? Okay. So, x minus quantity squared. What's half of half?
Fourth.
A fourth. Plus 1/4. Plus 1/4. So that's going to give me negative 2 over 4. Oh, I put it in the wrong spot. Stirrup must be going crazy. Did you get it?
Yeah.
Thank you. So 1/4 goes there. This should have been 1/16. This should have been 1/16. Okay. So we have to take care of this. I have to put this times 4 times 4, so I get negative 12 over 16 plus 1 over 16, which is negative 11 over 16. So I get minus 11/16. Okay. When we do root, we're going to get an I. But what's nice about the denominator of the aqua color? It's a perfect square. So if I take the square root of it, it's going to go bye-bye. Root, don't forget the plus minus. So I'm going to get I root 11 all divided by 4. Add 4 to both sides. Add 1/4. So I'm going to get this. Don't forget the plus minus. There's our answer. Huh. I kind of sort of like this stuff. It's like, yeah, but you're a math geek. Yeah, I am. Number 8. Is it set up, ready for us to complete the square? Or do I have to move something? What do you think? Ready to complete the square, or do I have to move something? Yeah.
Do you want to move the 4x to the other side?
Yeah, move the 4x to the other side by subtracting it. Good. So I'm going to get 4x squared minus 4x, leave a space, equals 2. You see the math we did? I don't like having the 4 in front of the x squared. Completing the square doesn't work as nicely. It does work, but it's a little ugly. Actually, I'm going to leave that as 2 over 4. I'm going to leave this as 2 over 4 right now. Because I think I see something that might happen. Actually, I'm going to make that 1/2. All right. So, it's ready to take half. What's half of 1 as a fraction? 0.5. 0.5 as a fraction is 1/2. 1/2 times 1/2 is 1/4. Yeah, I should have left that as 2 over 4. Plus 1 over 4. So that gives me 3 over 4. Root. Don't forget plus minus. X minus half equals root 3 over 2 plus or minus. And add 1/2 to both sides, so put it over one fraction if you would like. That's our answer. The reason I could put it over one fraction is the denominators were the same. Oh, this stuff is nice. Or do you guys want to go back to the quadratic formula? Raise your hand if you want to do the quadratic. Good, no one raised their hand. Woo, feel safe. Can I clear? Ready, set, bye-bye. All right. Last 2 questions, agree? Ooh, everything's a 3 on this one. Oh boy, oh boy. Let's see what happens here. All right, so I'm going to divide everything by 3. And I'm going to move that over. So I'm going to get x squared plus x, leave a space, equals positive 1. You see what I did? Negative 3 over negative 3 is negative 1. Add 1 to both sides. It comes down to that. Morning. All right. X plus. There is a 1 in front of it. What's half of 1 as a decimal or as a fraction? 1 over 2. 1 over 2 quantity squared is 1 times 1, which is 1. 2 times 2, which is 4. I'm going to change 1 to 4 over 4 because that's the same thing as 1, so I get 5/4 over here. Root, don't forget plus minus. Root 5 all over 2. Subtract 2, put it over one fraction. Done. Yee-haw. I love this stuff. I don't know why I like it so much. Maybe it's because I'm like, going to be 55 here in a few weeks. All right, number 10 is already set up to start completing the square. We just want to make sure we have a space. So 3x squared minus 4x, space. Before I do that, I need to divide everything by 3. So x squared minus 4 over 3, x. Negative 3 over negative 3 is negative 1. All right. Don't panic with the fraction. X minus. What is half of 4 over 3? What's half of 4 over 3? Double what? So it's 4 over 6? So 4 over 6. Can I reduce that? Yeah, 2 over 3. You don't have to reduce it. I was just going to reduce it. We wouldn't have to deal with a bigger fraction. It would still come out the same. So just realize sometimes if you do have a fraction, you might want to reduce it. If you don't reduce it, it'll still work at the end. All right, 2 over 3 times 2 over 3 is 4 over 9. So plus 4 over 9. Plus 4 over 9. I'm going to make negative 1, negative 9 over 9. That's the same thing as 1. That's going to give me negative 5 over 9. Now we're ready for our famous root. Don't forget the plus minus. So I'm going to get I root 5 over 3. Add 2/3. Keep it as one fraction. Done. That's it. That is it. Holy moly guacamole. I like this so much better. Did you all get it done? Cool. Put it in the book for you in a little bit. If you're absent, then watch the video. Can I clear?
Yeah.
Good. All right. All right. So, these are our notes for today. This is talking about the discriminant. The discriminant is, you remember the quadratic formula that we boycotted? And you have x equal to negative b plus or minus the square root. And then you have b squared minus 4ac underneath the square root. That's the b squared minus 4ac is the discriminant. Okay? So, let's take a look at this. And we've already graphed these before, but let's just take a look at how we do. All right, this is in vertex form. So you take opposite of what's inside, same of what's outside. Are we okay so far? Actually, let's, I'm going to make this bigger. All right, so opposite inside, same outside. So 6, negative 3, down there. Okay, this parabola opens up. Do you remember the pattern graphing we did? With the 1, 3, 5? So there's a number out here that's a 1, so it means our pattern graph is going to be 1, 3, 5. Opens up. So with this 1, 3, 5, I'm going to go right one up 1, left one up 1, right one up 3, left one up 3. So it basically looks like that. So, question for you. Does this parabola cross the x-axis? Does it cross the x-axis? Am I crossing this? Do I cross that? Did my pattern graph land right on it? No. So that means that these solutions here and here, this solution here and here, would have been, if you would have done the answer, it would have been like negative 3 plus or minus square root 5 all over 2 or something like that. That's not really what it is, but that's how the answer would have given itself if we would have solved it. Okay? So those are called irrational roots. An irrational root is something that has a radical in it. The radical in this case, I know that's not really the answer, but this radical basically means that I can't find those exact values. I can find decimal-wise kind of close, but not perfect. Number 2, vertex negative 5, and there's nothing back here. So if there's nothing back there, nothing in math is 0. So I get negative 5, 0, which is there. Okay, my pattern graph's going to work nicely because there's a 1 right there, so it's going to work with that. So I'm going to go, it opens up, so we'll go right one up 1, left one up 1, right one up 3, left one up 3. There's our parabola. Okay, does this parabola, can you see where it touches the x-axis? Is it a point? Yeah, it's called the vertex in this case. Okay, so if I had completed the square with this, like this is kind of an ugly one, the completed square, but if I completed the square, it's not going to give me like a fractional answer, and it's not going to give me 2 answers. It's going to only give me a single answer. Okay, can I move? We good to go? Clear that, kill that, move you over. All right, problem number 3. Problem number 3. Anyone want to give me a shout out with the vertexes?
1 and 4.
1 and 4, perfect. So 1 and 4. Okay, our pattern graph's going to work nicely with this because there's a 1 out front, so my pattern graph will still be 1, 3, 5, which we won't have to use all of it. Right one up 1, left one up 1, right one up 3, Left one up 3. Okay, friends, will this parabola cross the x-axis? No. So what this means is if I had completed the square, I'm going to get I as part of my answer. Okay? It means it's part of the imaginary number system, which is then part of the complex number system. It is very rare that the complex number system crosses the x-axis ever. It is possible in future math classes when you're dealing with some really weird looking stuff. But as far as right now, it's not crossing the x-axis. The solutions do exist, but it'd be like, a number plus or minus I root a number all over a number. Okay? All right, do we feel good so far? Can I clear? No coughing this time. All right. Convert the equation from vertex to standard form. Okay, gotcha. All right. All right, so I'm only going to